Good morning, students. So we discussed in last class. So that the topic is seventh chapter. So moving charges and magnetism, and so how to convert a galvanometer into a meter, and how to convert a galvanometer into voltmeter. Okay. So we discussed in a last class. So today discuss the another topic, another chapter. So that is the ray optics and optical instruments. Ray optics and optical instruments. So now in this chapter, so what is the ray optics? Okay, and so optical instruments are the taken. So that is called as a, what is the focal length, what is the focus, and what is the principal focus, etc. And so the lens rules are taken, also we discussed. Okay, so etc. What is the importance of the microscope scoping of the, okay, so etc. we discussed in this chapter. So now today we discuss about the first of all, so some what is the focus. First of all we discuss about the focus. So what mean of the focus? So focus is nothing but here, so this is called as the, so that is called as a, the layer, that is the mirrors, the curvature mirrors. Okay, so lens are divided in two types. So one is taken concave and another is taken convex. So concave, convex. So concave means Putakara Katakal. Okay, so next convex means Kumbhakara Katakal. So convex and concave. Okay, so now here taken. So what is the focus? The focus is nothing but, so the image of the object, okay, is formed infinity. So the image, this is called as a concave lens, concave. So concave, this is called as a concave, and this is called as a convex. Okay, and also we discuss about the double convex and double concave. Okay, so now here, what is the focus? So the focus is nothing but, so the image of the object is formed at infinity. At infinity is called as a focus, focus point or focus. At that point is called as a focus point. So now here, so the image is formed, the image is formed due to the object here taken. So the image is formed. Okay, at infinity is called as a focus. Okay, got it. So now another one is taken. So principal focus. So next one is taken. Principal focus. So what is the principal focus? So the principal focus is nothing but, so this is called as a concave lens, concave mirror. So this is called as a principal axis. Principal axis. So the incident ray is parallel to the principal. Okay, so parallel to the, and so is reflected at an instant or merging of the at one point, merging the point. So this like just so the point is called as a principal focus. Principal focus. Pradhanamainatuvanti aksham, nabi oka aksham. Okay. So that means here taken. So this is called as a parallel beam to the principal axis and instant, and so that is called as a refraction at instant on a, so principal focus. So this is called as a principal focus. Okay, got it. So what is the focal length? Okay, so the focal length is nothing but here taken. So this is called as a principal axis. So the focal length is taken. So instant and get reflected, and instant and get reflected. Okay, so the principal focus. So what is the so the length of the so the focal length. What is the focal length? What is the focal length? So this is called as a pole of the mirror. Pole of the mirror. Okay, or lens, pole of the mirror. The distance between the focus to pole of the mirror. the distance between the focus to pole of the mirror is called as a focal length. Okay, this is called as a focal length. So the distance between the focus to and pole of the mirror of the concave lens is called as a focal length. Okay, got it? Right. So now next one we discuss what is the curvature, center of the curvature. Okay. So what is the center of the curvature? So now we have taken, this is called the center of the curvature. So this is called as the focus F. It is denoted by, and center of curvature is taken C. So what is the center of curvature? Center of curvature is nothing but, so the curvature is the one part of the sphere. Okay. Now we have taken, this is called as a sphere. So this is called as a radius. And so the part is cutting. Okay. So one part of this is called as a spherical sphere. Okay. So spherical sphere. So spherical sphere is taken as the one part of the sphere. Okay. So already we discussed in a 10th class. Okay. So what is the principal focus? For example, here taken, this is called as a concave lens. Okay. So concave lens. So this is called as the principal axis. Okay. So principal axis is normal to the concave lens. Okay. And so this is called as an incident. Right? So just like incident. So this is called as a focus. F. It is denoted by. So the length between the focus to pole of the mirror is called as a focal length. And also, so if in case of the taken, so convex lens, so this is called as a principal focus, and so incident light, just like here. Okay. So this is called as a focus. Okay, so of the convex lens and also concave lens, so we discuss it. Okay, right. So the next one, what is the focal length, what is the focus, etc. we discuss. Okay, so now another one is topic is taken, what is the Cartesian sign convention. Cartesian sign convention. So here taken, that is the lens, concave lens or convex or concave lens. Okay, some mirrors is taken. But here, so that properties are, okay, we study about the some particular rules, that is called as a Cartesian sign convention rules. Cartesian sign convention rules. So the Cartesian convention we have taken. So this is called as a principal axis of the mirror. So we are taking the mirror. Okay. So principal focus, principal axis, principal axis. Now we are taken, so incident ray. So this is called as incident ray. And so this is called as a, we are taking the focus and center of the curvature. Okay, so heights upward direction, heights upward direction, and heights, so heights are downward direction. Direction. Now we are taking along the instant. So we are taking, this is called as a heights upward direction is taken positive. Here negative. Here also. So along the x direction is taken positive. Okay. So that is nothing but we have taken, so that means along the x direction, along the principal axis direction, along x direction, direction. The distance are taken positive. Distance are taken positive. Got it? Positive. Okay. So the distance are taken against. Okay. So the distance are taken. Distance are taken against. The distance are taken against. Okay. Is taken negative. Okay, negative. So this is called as a mirror. Okay. So now here, so this is called as a incident ray, and so the Cartesian sign convention rules we have taken. So now first of all, so this is called as a concave mirror, and so this is called as a principal axis, and so this is called as a pole of the mirror. P is called as a pole of the mirror. Pole of the mirror. Okay, got it. So all the distance are measured. First point, note that. So all the distance are measured from the center of the pole. All the distance are measured from center of the pole of the convex lens. Okay, got it. Or concave lens or mirror. So water may be taken. All distance are measured from the center of the pole. Okay, pole of the mirror. Okay, got it. So now next one here taken. So the heights are upward direction. So heights are measured. Upward direction is taken positive. Okay, and also so the heights are measured downward direction. Heights are measured downward direction is taken as negative. Okay, got it. And so that means the distance are measured along the x direction, along the axis is taken as positive. Okay, so along the incident ray, all the distance, that means so the distance are measured along the incident ray, is taken as positive. Okay, got it. And so now here taken another, so the opposite to direction of incident, or against to direction of the incident, all the distance are measured, okay, as negative. Okay, got it. So the four particular rules are applying lens or mirrors. So first point is taken, all the distance are measured from the center of the pole of the mirror. Pole means dhruvam. Pole of the mirror. So now next one is taken. So that is, so the heights are measured. The heights are measured along the upward direction is taken as positive. And also the heights are measured downward direction is taken as negative. Okay, got it. So now here taken, so that this is called as an incident ray, and all the distance are measured along the incident ray is taken as positive, and all the distance are measured upward to or opposite to incident ray. So this is called as the incident ray direction, and opposite to or against to the direction of the incident ray is denoted or noted as negative. Okay, got it. So this is called as the rules of the Cartesian sign convention. Okay, right. Now another one is taken, so that is called as a, so the relation between focal length and center of curvature. center of curvature. So that means center of curvature and R and F. Okay, got it. So now we have taken now here see that the ray diagram of the relation between the focal length and center of curvature or radius of curvature. Okay, so that means radius of curvature, R and F. So now first of all, what is the focal length? So the focal length is means so the distance between the focus to principal focus. Okay, focus to pole of the mirror. Focus to pole of the mirror is called as a focal length. So what mean of the focal length? So the distance between the focus to pole of the mirror is called as a focal length. And also we discussed the relation between focus and radius of the curvature. Okay, now prove that. So R is equal to F by 2. Okay, good. So that is here taken. So first of all here, so this is called as a incident ray, AB incident ray. Okay, so the AB is incident ray is parallel to the principal axis. So this is called as a principal axis. So the AB ray is the parallel to the principal axis and incident at a point B and get reflected and passing through the F along the BF. Along the BF. Got it. So first of all, so the AB ray is taken. So at incident at a point B on lens and get reflected. So passing through the BF. Okay, got it. Right. So the next one here taken. So here taken. So the triangle. Okay, so the triangle is taken. So A, B, C is equal to theta and so B, C, P is equal to also theta. Okay, so the angle A, B, C is equal to angle B, C, P is equal to theta is the angle. Okay, got it. So now here, so the CP is a perpendicular to the lens or normal to the lens. Okay, got it? And so now we are taken so the BD line. So the BD is perpendicular to the CP. BD is perpendicular to the CP. We can draw this. So that means 90 degrees we have taken triangle. Okay. So now here, so the consider the triangle BCP triangle is taken. Okay. So BC. Okay, so BCD is the triangle is taken. BCD. Okay, consider the BCD is triangle is taken. This is called as a triangle. Okay, now tan theta is equal. So tan theta is equal opposite side by hypotenuse. Opposite side means here taken BD is called as a opposite BD. By hypotenuse is taken. So that is called as a C. Okay, C. D is called as a hypotenuse. CD. Okay, got it. So now another the triangle, this is called as a equation 1. And so now another triangle is taken, so that is called as A. Okay, so BFD, that is a tan 2 theta is equal. Okay, so opposite by hypotenuse, that is called as a BD by FD, equation 2. Okay, got it. So now in this equations, BD by CD and BD by FD, and so now here the tan theta, that the equation 2 is divided with respect to equation 1. Equation 2 divided by equation 1. So tan 2 theta by tan theta is equal. Okay, so BD by FD, and so BD by CD is taken. So BD are cancelled. CD by FD we can write. Okay, got it. So now here taken, that is the CD. CD is approximately CP, because so the D line or D point approximately or that means so the that is means CD is equal CP we can write. That means CD is equal to approximately CP. Okay, so very close to or lies, the D point is lies on a point P. That means here the CD is equal CP. Here ఇక్కడ మనం తీసుకున్నటువంటి లెంత్ లేదనుకుంటున్నాను కదా, అక్కడ లెంత్ లేదనుకుంటున్నట్లయితే T పాయింట్ ఎక్కడంటూ P పాయింట్ ఉన్నట్టే కదా. So the CD we can write the CP. Okay, got it. So and so the theta is very small. Here if the condition, if theta is very small, okay, very small, so we consider the tan theta is equal theta. Tan theta is equal approximately theta, and also tan 2 theta is equal approximately 2 theta. Okay, got it. And if we consider the theta is very small, and so the D point is completely lies on a point P. Okay, so that means CD is equal CP we can write. And if the theta is very small, so that means so that is a small aperture. So the tan theta is equal approximately theta, and tan 2 theta is equal approximately 2 theta. And substituting in this equation third, we get so 2 theta by theta is equal. So CD by FD, CD is equal CP we can write, and FD is equal FP we can write. Okay, got it. So the CP is means CP is the length that is called as a radius of the curvature. So CP is equal to radius of the curvature, or we can write. And so FP, so FP is equal focal length. FP is equal to focal length we can write. Okay, got it. So now substituting in the equation, so 2 theta by theta is equal to R by F. Theta are cancelled. So R is equal to F, or F is equal R by 2 we can write. So that means so the radius of the curvature is equal to the, okay, so the double of the focal length. That means we can write another pattern also. Observe. So F is equal, focal length is equal half of the radius of the curvature. Okay, got it. Okay, so that is called, now prove that R is equal to F, or F is equal R by 2. F is equal R by 2 means here F is equal, so the total R by 2. Now prove that. Okay, got it. So what is the focal length and what is the radius of the curvature? Okay, and so now prove that the R is equal to F. Okay, got it. So now we discuss the another topic. So what is the critical angle, and so what is the total internal reflection? Critical angle, and what is the total internal reflection of the light, okay, in a denser medium and etc. rarer medium. Now we studying about the, so another class. Okay, so today class is over. Okay, thank you students.